Hey Dons, this is Mr. Sipple, and I'm here with the Test 3 retake for Algebra 1. So what I'm going to do is I'm going to go through some of the questions just as a review, and then since we're doing this on Edpuzzle, the video will stop. You'll answer a question, and then we'll go on to the next one, you answer, and then so on. And then we'll repeat that for the questions. All right, so taking a look at the first question, this unit dealt with patterns, and this is a tile pattern, patterns in numbers, patterns in a graph, patterns. That was our theme here. So what we want to do is, first of all, if they give us this picture, what we want to try to do is then figure out what kind of pattern is going on here. Well, let's figure out how many tiles there are. So it's 1, 2, 3, 4. So what I would do is I would write the number of tiles 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what I want to do is then take a look at how is this changing each time? Well, from 4 to 7, that's a change of 3. And from 7 to 10, that's also a change of 3. So it looks like it's going up by 3 each time. So if we want to know how many figure 4 would have, what we're going to do is we're going to go forwards in time, and then we're going to go backwards in time. So we're going to go back to figure 0. What would that be? And then what would figure 4 be? Well, if we're adding 3 each time, that means that, and if I do another plus 3, that means that figure 4 would be 13. And then if I count backwards, so instead of saying 4 plus 3, if I say 4 minus 3, that would be 1. And then I could check to see if that's right, because if I did 1 plus 3, I get 4. So I know that would be correct. And now what we want to be able to do, though, is because what if I wanted to know the 200th figure, right? And that's actually part C here. We're going to want to know the 200th figure. Well, what I don't want to keep doing is I don't want to keep doing plus 3, plus 3, plus 3, plus 3, plus 3 until and do that 200 times. So we're looking for a shortcut. And so the shortcut is for our tile pattern is we write it in the form of y equals mx plus b. And so with y equals mx plus b, the m represents the rate of change, right? The slope, right? This is our rate of change. And then the b represents our starting amount, right? Our starting point. So our starting amount or starting point. And you think about a stopwatch starts at 0, right? So that's why we count back to figure 0, because this is the 4 is the first number in the sequence, right? That's figure 1. Well, when we think about the beginning of something, we think about where was it at when it was at 0. So that's why we had to count back. And so this represents our starting amount. So then what I would do to write that in the equation just would be y equals our rate of change, which our rate of change in this case was 3. So it'd be y equals 3x plus, where did it start off at? Well, where it started off was it started at 1. So my equation would be y equals 3x plus 1. I can check to see if that's correct, right? Because figure 3, if I look at figure 3 has 10 blocks in it. So what happens if I plug in 3, right, for the third figure? Well, I get 9 plus 1, which is 10. So that's a way that I could check to make sure that I have the correct formula, or we call it a couple of things. We call it a shortcut. We also call it the rule. So how many tiles are in figure 200? Well, all I would need to do is that means that if x is equal to 200, what would y be equal to? Well, I'm just going to take that, y equals 3x plus 1, and then I'm just going to substitute this into my rule. It's my shortcut. I'm going to take that x equals 200. I'm going to plug that in. And so I would have y equals 3 times 200 plus 1. And then when I do the number crunching there, 3 times 200 is 600. 600 plus 1 would be 601. So I would have 601 tiles. And that's a way for me to find that out without having to count plus 3, plus 3, plus 3, right? Nobody wants to do all that. All right, so that was number 1. So we'll pause here and let you try number 1, and then we will move on to number 2. Okay, let's take a look at number 2. So we want to determine if something is an arithmetic sequence. So we know that a sequence is just a list of numbers, right? And I got the definition here from my toolkit. So a sequence is just a list of numbers, right? But it's not just any list of numbers. There's a certain pattern to it. And the pattern is that it adds or subtracts by the same number each time. So what we say is that the difference is constant. So adds or subtracts by the same number, right? So we could say adds or subtracts by the same number. By the same number. Okay, so either it adds or subtracts by the same number, or it's just a total random list of numbers, or there's a third type of pattern we're going to see here, which changes because you're multiplying, which is a different type of sequence. We call that a geometric sequence. Here we're looking just at arithmetic. So let's take a look at each one of these sequences here. -20, -17, -14, -11. That's going down by 3 each time, right? So that would be -3, -3. So that would be an arithmetic sequence. So this, I'm just going to write A for arithmetic. 5, 8, 13, 21. Well, that goes up by 3, and then it goes up by 5, and then it goes up by 9. So it's not going up by the same thing each time. So this would not be an arithmetic sequence. Let's look at this one. It goes up by 2, goes up by 4, then it goes up by 2. Again, what we're looking for is that it goes up by a constant amount. It can't fluctuate, right? It can't go up by different numbers each time. So that would not be arithmetic. 7, 11, 15, 19, that goes up by 4 each time, right? So this goes up by 4 each time. So in this case, whereas this went down by 3. So this goes up by 4, so this would be arithmetic. 4, 16, 64, that looks like it's being multiplied. Well, what we're looking for arithmetic is only addition or subtraction, so that would not be an arithmetic sequence. 58, 48, 38, 28, that's going down by 10 each time, so that would be arithmetic. And then this is going -25, -30, that's going down by 5 each time. So in this case, that would be also arithmetic. And then this last one, 40, 20, 10, and 5, that's being cut in half. It's being divided by a number, right? Multiplied by 1/2. So that would not be arithmetic. So the only ones that are arithmetic here would be this sequence. It's going down by 3, this one that's going up by 4, this one that's going down by 10, and this one's going down by 5. So those would be your arithmetic sequences. All right, so we'll pause here and let you try number 2. Taking a look at number 3, so we are working with an arithmetic sequence, so it is changing by the same amount each time. So the first thing that we want to look at is, well, what is it changing by? Well, if I compare 22, 26, 30, and 34, what's happening there is it's going up by 4 each time. So we would say +4 and then +4. So those are all +4 each time. Our name for that, we call that the common difference. The common difference just refers to what the sequence is changing by. So what the sequence, so we could say number, let's say number, the sequence is changing by. So it's kind of the key to the pattern, right? So what it's going up by 4 is going up 4 each time. So we say the common difference is 4. What we want to be able to do is we want to count backwards to the 0 term, because if I take these numbers, 22, 26, 30, and then 34, this represents the first number, right? This represents the second number. This represents the third. This is the fourth number. Well, but again, when we mark time, we mark the beginning of something at 0. So what I have to do here is I have to count backwards to what I call the 0 term, right? This would be the 0 position. Well, if it's going up by 4, I just would subtract 4. So if I subtract 4 from 22, I get 18. So that would be my 0 term, would be at 18. And now what I want to do is write the rule, similar to a slope-intercept form, y = mx + b. When we're talking about a list of numbers, we just use a sequence notation. Remember, math is a language. Just like with any language, you have different ways you could say the same thing. And so, whereas this is written in, the last problem we wrote in slope-intercept form, or number 1 rather, we're going to write this in what's called a sequence notation. But just know that this is the same thing as y equals mx plus b. The rate of change and where it starts. We actually already know all of this. So the rate of change is 4. So it would be 4n. We're using n instead of x because of the notation. Plus where it starts, which would be 18. And then we're going to find the 30th term. So if we want to find the 30th terms, that's just when n is equal to 30. So what I'm going to do is I'm going to say a sub 30. And we just say a sub because it's the notation that 30 is written a little bit smaller. Just a placeholder. It tells us which number in the sequence we're looking for. So we're looking for the 30th number. So I'm going to say 4n plus 18. And then what I'm going to do with this is I'm going to take, if n is equal to 30, because that's what they're asking me to find, I'm going to substitute that in right there. And then I'm going to figure out what the rest of this is going to be. And so this is a way, instead of me having to count plus 4 plus 4 plus 4, this is a shortcut for me. And this would be times 4. Don't want to forget that guy. And I would say on all of this, this isn't mental math class. There's no reason why you can't use a calculator. So I would use a calculator for this. If you're not sure, you don't want to get it wrong just because you were trying to do some mental math and you made a silly little mistake. So I would tell you, use a calculator for this stuff. So let's do 4 times 30, which is 120, plus 18. And so we get 138. So if we kept counting by 4s, and we did that 30 times, we end up at 138. All right, so that's number 3. Pause here and try number 3 on the puzzle. Taking a look at number 4. So number 4 is just another sequence question. Same exact question as number 3. The only difference here is that our common difference, instead of our sequence increasing, instead of going up by a certain number, if we take a look at this, we can see that it's going down by a certain number. So let's take those numbers, 212, 197, 182, and 167. And then let's find the difference there. On that last problem, I was telling you, don't be scared, use a calculator if you need it. Well, let's find the difference. So I would say 197 minus 212. I'm just taking the second number and I'm subtracting it from the first one. So I could see that it's going down. In this case, it's going down by 15. Be careful there, because if you had said 212 minus 197, you would have got 15, but it's not going up by 15. The sequence is going down by 15, so be careful there. So our common difference is 15. What if I count backwards? So let me count back. This was my 0 term. So if I'm at 212, and then it's going up by 15, down by 15, right? Then if I want to go the other direction, if I want to count back to my 0 term, then I'm going to have to add 15. So let me do 212 plus 15, because I'm going the other direction. So 212 plus 15, because it's getting smaller, I'd be at 227. So this would be 227. That would be my 0 term. So now that when I want to put all this together, so my rule is what it's changing by, which is negative 15. And then where did it start? It started at 227. So if I want to find the 30th term, I'm just going to take 30 and I'm going to plug it in. Actually, since I already have it written, why don't we just do that right there? So we'll drop in the 30, and then we'll say times negative 15 plus 277. And then let's go to the calculator on this one, just to make sure we don't make any mistakes. So negative 15 times 30 plus 277. And we get negative 173. So the 30th, and how we would write this, by the way, so we'd say a sub 30, this 30th term in the sequence is negative 173. And that should make sense, because if you kept counting down by 15, like eventually you're going to hit 0, and eventually you're going to go past 0 into the negative territory. And so if we did that enough times, that's where we'd end up. All right, so that finishes up number 4. Pause here, try the next one, and then we'll move on to number 5. We said that the pattern, we're looking for patterns here. In this case, we're looking for a pattern in the graph. So what we want to be able to identify is what's the slope and what's the y-intercept. I think of these problems in this kind of fashion here, which is that I want to know what's the slope and then what's the y-intercept. I almost kind of think of this as like a fill in the blank here. Because I know the answer is going to be y equals something. I just need to know what the slope is. I need to know what the y-intercept is. Well, let's start with the y-intercept here. It looks like this starts at -1, -2, -3, -4. So the y-intercept is there at -4, so I could go ahead and fill that in. Now I just need to figure out what the slope is. Remember that slope is the change in y over the change in x. And when we're talking about a graph, at least in this context, we're talking about the steepness of a line. So how is the line from one point to the next point, which the next point marked here is here, how many do I go up and how many do I go over? And we're always looking at this graph, by the way. We're looking at it from left to right. So I want to ask myself, how many did I go up? And then how many did I go over to get to that point? Well, it looks like I go up 2 and then right 3. So when we write our slope, the slope is how many did you go up or down? In this case, we went up. And then how many did you go to the right? Well, we went up 2, right 3. So that means my slope would be 2 over 3. If that's a fraction I could reduce, I would reduce it, but nothing I can do with 2/3. So we're just going to leave that as y equals 2/3 x minus 4. We'll go ahead and do the next problem as well. It's going to be the same exact thing, but instead of it being a line that goes uphill, it's going to be a line that goes downhill. But I'm going to approach it the same way. So I'm going to say y equals something x plus something, right? I'm just kind of filling in these blanks. So my first something is, well, what's the slope? My second something is, what's the y-intercept? And I don't have to really do any work here. I just look at the picture. The y-intercept, right, which is where the line crosses the y-axis, the y-intercept is at 2, and now I just got to figure out what the slope is. Well, let me see my other point that's marked here. What I'm doing is I'm looking down. I'm looking for where it crosses a corner, right, where the line goes through the corner of one of the boxes. And so it looks like it crosses at that point right there. Now what I'm doing, remember we said what slope was, right? Slope is our change in y over our change in x, which again means how many did you go up or down? Up if it's positive, down if it's negative. And then how many did you go to the right? Well, in this case, and if I don't want to write the word slope, right, we use the letter m to represent that. So it looks like I'm going down 1, 2, 3, and then over 1. So it looks like my slope would be -3 over 1, which I could just simplify to -3. So then my final answer here would be y equals -3x plus 2. And you can always test another point. You know, if I keep writing this down, I find another point right here, then notice what happens. It's the same thing. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1, right? So it looks like this little staircase. Down 3, right 1, down 3, right 1, and then so on. All right, so we'll go ahead and pause here. So go ahead and do 5 and 6 on the Ed puzzle. Taking a look at number 7, it says Mr. Flores is buying some of the supplies for a pizza party. He's got to pick up the peppers and mushrooms. Peppers are $1.50, mushrooms are 25 cents. He spent $11 total. Write the equation in standard form. So standard form, different than slope-intercept form, right? Where slope-intercept form, the y is by itself. In standard form, you've got something that looks like this, where I kind of think of this as that usually buying 2 different items of something. So like, let's say that this represents your first item that you're buying. And then this represents your second item that you're buying. And then the C is going to represent the total for the 2 items. And because we're talking about money here, so this is going to be the cost of the first item. This is going to be the cost of the second item. And then this is going to be the total, maybe we'll squeeze in here, total cost for the 2 items. So, well, how much is the first item? They're telling us to use X for peppers. So that would be, for peppers, we're saying there's $1.50 X. Plus, for the mushrooms is 25 cents, so 0.25. make sure you're careful with the decimal, right? It's not $25 for mushrooms. That's an expensive mushroom. 25 cents for the mushroom. And then that adds up to $11. So for part A, I'm actually not doing any math here. I'm just setting up the equation to represent the situation. Now, in the second part here, it says if Mr. Flores bought 4 peppers, remember, peppers we're representing as the letter X. So that means if X equals 4, then what does Y equal? Right, which is mushrooms. So let's substitute that in. So we've got a $1.50X plus 0.25Y equals 11. So what we're going to do is we're just going to substitute in X, right, which X equals 4 in this case. I'm going to drop it off right there. And then let's see what Y is equal to. So $1.50 times 4. Well, $1.50 times 2 is $3. Double that, that'd be up to $6, right? So this would be $6 plus 0.25Y. Forgot my Y there. If I subtract 6 from both sides, right, 11 minus 6 would be 5. And then divide both sides by 0.25. And Y would equal, and just to be safe and make sure we get it correct, let's go ahead and put that in. So we're saying 5 divided by 0.25, and we get 20. So that means that Mr. Flores bought 20 mushrooms. 20 mushrooms. Number 8. So another word problem. I guess we call these word problems. You know, they're not really word problems in the sense that, I mean, they pretty much give us everything we need to know here. It says that Miss Lou, zoom in a little bit on this. Miss Lou's going to a Star Trek convention. So it costs $52.50 to get in. And then they charge $12 per signed action figure. So when you see that per, P-E-R, you're thinking that's the slope, right? Because that would be the rate of change, because slope represents rate of change. And then your y-intercept represents the starting amount. So whether we're talking about a graph, a list of numbers, or in this case, we're talking about how much it costs to get in, right? So this would be your starting amount, $52.50 just to get in, and then it's $12 per action figure. So the slope in this case would be 12. The y-intercept, which is how much it costs to get in, is $52.50. And then so we want to write that as an equation. So we're just going to put these two things together. So we'd have 12x plus $52.50. And then it asks, what's the total amount if she paid to get 6 action figures signed? Well, X represents our number of action figures, right? So X equals number of signed action figures. So what they're saying is, well, how much would it cost if you did 9 of them? Well, that's just saying, well, what if X is equal to 9? Well, we're going to take that and just plug it in. So we've got y equals 12x plus $52.50. And we're going to substitute in this 9. So we're going to say if x equals 9, and we're going to plug that in right there. And again, we'll use our calculator to help us do the math. No reason to get this wrong because we made a silly little mistake. So let's put that in the calculator. So 12 times 9. And then we're going to add to that what the initial cost was just to get in to the convention, which was $52.50. So if she got 9 signatures, that means that we spent a total of $160.50. That's okay. You're a big fan, so it's worth it. 160, or she's a big fan. 160.50. Number 9. So no story here. We're given a slope and we're given a y-intercept. Well, so if we think about what's happening here, the slope, because again, we're trying to fill in kind of the same fill in the blank as we looked at the graph. What's the slope? And then what's the starting amount, right? So this is the slope, and this is the starting amount, the y-intercept. Y-intercept. Well, they tell us what the slope is. We don't have to hunt for it. They tell us straight up what it is. The slope is negative 3/5. So my slope is a negative 3/5. I didn't have to do anything to figure that. They just gave it to me. And the y-intercept, if we notice what the y-intercept is, the y-intercept is always, if you think about the graph, it doesn't matter where I'm at on this graph. What's the x value of any one of these points, right? The only thing that's changing is the y value. The x value is not changing at all because you didn't go left or right at all. So the x value would be 0. So when x is equal to 0, I'm just going to make a note here. So when x equals 0, the y value, or the y number, is the y-intercept. So I actually don't have to do any real math on this one. So I'm just taking this, which in this case would be 4, right? That number right there. And so that would be my y-intercept. Now that's only when x equals 0 can I do this. So if the x wasn't 0, I need another approach, and we're going to look at that in the next question coming up. But if the x is equal 0, then I can just steal the number from there. So that means that my answer would be y equals negative 3/5 x plus 4. Now on number 10, so this is where I actually have to maybe do a little math here. So the same approach here, I just want to know what's the slope, what's the y-intercept. And I'm starting all these problems the same way because I just want you to have a visual of what we're trying to do. From the story or the information they give us, we just want to figure out two things. Where did the pattern start, right? Because that's what the y-intercept represents, the starting amount. So where did the pattern start and how did it change by, right? So remember, the B represents starting, right, where it started. And then the M represents what it changes by. Right? So we bought a car. It goes down by $3,500 per year. Well, right away, that's telling me change. So, and it's going down. Depreciation means to go down in value. So that's a negative $3,500. And then it says that after 4 years, the car is worth $15,995. So x is not 0 here. So this is not the y-intercept, right? So I can't just plug that in. I do know what the slope is. The slope is negative 3,500. They gave me that for free. But I've got to figure out what the y-intercept is. Well, so this is where we have some point slope form. What this does is that if we're missing the y-intercept, we're going to use this. We use this when the y-intercept is not given. They gave us a slope. They just didn't give us the y-intercept. So what I'm going to do is I'm going to take the numbers that are here. And so I've got y. And then so this is going to be they do give me an x and they give me a y. So I'm going to call that x1 and y1. So my y1 is 15,995 equals my slope, which they gave me that. I got that for free, which is negative 3,500. And then that's times x minus x1, which would be 4. And then all we need to do is simplify this, and then this will put it in slope-intercept form for us, and this will tell us what the y-intercept is, that missing piece. So, well, let's do our distributing first. So I'm going to leave the left side alone for a moment. So let's go ahead and distribute this negative 3,500. So I would have negative 3,500x. And then negative 3,500 times 4. Let's just go ahead and put that in a calculator to be safe. But if we doubled 3,500, that would be 7,000. Double that again, it would be 14,000. So 3,500 times 4, right, which would be 14,000. A positive, right? Because those two negatives make a positive. So let's add 15,995. So what this is saying is that in 4 years, the car has lost $14,000. So let's add what the car is worth at 4 years plus what it lost, and then that should tell us what the car started at, right? That's our y-intercept. So negative 3,500x, and then that would be 29,995. So my y-intercept would be 29,995. What would the car be worth in 7 years? Well, after 7 years, what that's saying is that when x is equal to 7, what would y be equal to? Well, we're just going to plug it in. It's just another substitution here. Negative 3,500x plus 29,995. I need that in the way. Should have turned that off a long time ago. That's all right. So let's take 7, plug it in, plug it in, plug it in. Negative 3,500 times 7 plus 29,995. We already know that negative 35 times 4 was 14,000. Let's figure out what negative 35, so negative 3,500 times 7, negative 24,500. And then our car is not going to be worth all that much. So let's add 29.95 to it. So plus 29,995, and we get 54.95. So 5,495. Right. Is that a ripoff? I don't know. You might think so. So maybe some people don't buy new cars for this reason. They wait a year or two for it to depreciate a little bit, and then pick it up at a discount. Number 10. There it is for you. Let's take we've got two problems left. Hang in there. All right. So, well, actually, we're going to make a couple more, but hang in there either way. All right. So this is the same type of problem. It's just that now there's no context. It's just some random numbers. But what we do know is here's an m, negative 7, and then here's an x, and then here's a y. So what I do know is I do know what the slope is. So that's given. So in my two things that I'm looking for here, slope and y-intercept, I do know what the slope is. The slope is negative 7. The only thing I don't know is I don't know where it starts, right? Like where this pattern starts. So what I'm going to do is I'm just going to substitute in a point slope, and that's going to tell me where this thing started. So I'm going to say y minus y1 equals m times x minus x1. And by the way, where this comes from is that we know that the formula for slope is y2 minus y1 over x2 minus x1. So if we just rearrange this, which basically means just multiplying both sides by the denominator here, then we end up with that. So it's not magic. It comes from somewhere there, and that's where it comes from. Our y1 in this case would be negative 2. The only thing you got to be careful about, watch out, because this is already a minus, and then that's a negative. So in a second, we're going to turn those 2 into a plus. But I would write it first with the parentheses just to make sure you don't make a mistake with the sign. Slope's negative 7, and then x minus 1. So what we're going to do is we're going to change this minus into a plus, right? So that's really going to be y plus 2. And then we'll just distribute, right? Distribute to both. And then we just need to subtract 2 from both sides. And so we get y equals negative 7x plus 5. So what that means is that this pattern, the y-intercept for this pattern, is no longer a mystery. I know what it is. It's 5. So my equation would be y equals negative 7x plus 5. Number 12. 2 more problems now, I think. Yeah, so we've got 2 left after this. Or 1 after this. All right, so they're giving us some information. So this is the same thing. I'm going to write this now for like the millionth time. Y equals blank x plus blank. And again, my 2 blanks that I'm looking for here. The first blank is the slope. What is it changing by? And then the second blank is what's the y-intercept? Where did it start? Well, you notice on the last one, they actually told us what it was changing by. However, if you look at this one, they tell us that 400 square feet goes for $2,800, and then 700 square feet goes for $3,400. So, bigger the place, the bigger the rent, right? But what they're not telling us is how much are they charging per square foot. So we don't know what the slope is. So we have kind of two unknowns here. We don't know what it is per square foot, like how much they're charging us per square foot, and how much are they charging just for us to sign the lease, right? Because a lot of times you might be charged for something, an upfront charge, and then per, in this case, whatever the square footage is. So we have two unknowns that we're solving for here. Well, we need to find the slope. How do we find the slope? Well, we did that earlier on the graph. We said that slope is the change in y over the change in x. So let's just figure out what the change in y is here, right? And again, I forgot to mention earlier, but that little triangle, it's just the Greek letter delta, which means change in. So it's just our little shortcut. Instead of having to write the words change in, we just write the little triangle. But I'll go ahead and write it now for fun. Change in x. All right, so how do we find the change in y, change in x? Well, let's figure out what the change is. So if you go from 2,800 to 3,400, what is that a change of? Well, that's going up $600. And if you weren't sure, just take a calculator and just do 3,400 minus 2,800. Your calculator would need to be on first to work. How about that? 3,400 minus 2,800, you get $600. Right? What's the change from 400 to 700? Well, the change in x, to go from 4 to 700, that's going up 300. So then if I want to know what my slope is change in y over change in x. My change in y was 600. Change in x was 300. So then if I divide that, I get 2. So I messed up my color scheme here, but my slope, my m, is going to be equal to 2. So that means they're charging $2 per square foot. But then you're like, wait, but so 400 times 2 is only 800. So where are they getting this 2,800 from? Well, that's because they're charging us something up front. And even as I said that, I could probably figure out, 400 times 2, 800. But they're charging me 2,800. Well, what's the difference? The difference is 2,000. So I'm thinking the difference, the y-intercept, I'm thinking the y-intercept is going to be 2,000. But I'm going to put a little question mark here because I'm not sure. I'm just kind of thinking aloud there. So let me actually just plug this in and then see what it would be. So what I would do is I'm going to take y. I'm going to take my point slope form right here, right? Because remember we said, this is what we said on the last one. Which is that we use when the y-intercept is not given. So use the point slope when the y-intercept is not given. Y-intercept is not given here, so we're going to use that. So I'm going to take y minus y1. Now you're like, well, which one's y1? Well, the good news is it actually doesn't matter. You could use this as your x1, y1, or you could use this as your x1, y1. Doesn't make a difference, so whatever, just pick something. So y minus, just pick a pair, but don't mix and match. You can't take an x from here and a y from there. So it has to just be from the same pair. So y minus 2,800 equals the slope, which we know now is 2, minus x1, which would be 400. So let's kind of simplify what's happening here. So we get 2x minus 800. And then let's add 2,800. And then we're going to out of room there a little bit, but we get y equals 2x plus 2,000. So my estimate there that 2,000 was the y-intercept is correct. So I get my answer there of y equals 2x plus 2,000. Now it's asking how much would it cost if we wanted to do a rental of 2,300 square feet. Well, what that's saying then is that what if x was equal to 2,300? Well, if it was, I'm just going to plug it in. So let me take 2,000, right? I'm taking my rule. And then I'm just going to substitute this in. So I'm going to take, if x is 2,300, I'm just going to plug it in. So 2,300. And again, we'll use a calculator to be safe here. We don't want to make any silly little mistakes. So if we double 2,300, it's going to be 4,600. And then add in the initial charge just to set up the lease here. So we get a total of 6,600. So our total answer or final answer here would be 6,600. Congratulations, you've made it to the end. Here's our last question, and then we're all done. This question is the same exact question as number 12. The only difference is number 12 gave us a context. There was kind of a story behind what the numbers meant. In this case, the numbers are just random. So we don't know what these numbers mean. But what we do know is that even if it's random, it still has a pattern, right? Which is to say that it still has a starting point. So we're still looking for that slope. Rate of change. It has a rate of change. So we're still looking for that slope. And then it had a starting point. So we're looking for the y-intercept. Neither one of these things are given. So you notice the slope, y-intercept, both question marks, both mysteries here. I don't know what the slope is, and I don't know what the y-intercept is. So for slope, again, slope is change in y over change in x. So let's start with that. And let's figure out what the change in y is here. So to go from 1 to -5, what is that a change of? And when I say change, I want you to visualize, by the way, a number line. So if I'm at 1, 1, 2, 3, 4, 5. If I'm at 1 and I want to go to -5, how many steps did I take? 1, 2, 3, 4, 5, 6. And in what direction did I take those steps? Well, I took those steps in the negative direction. So my change in y is going to be a -6 because I took those steps down. And then if I go from -4 to -2, what is that a change of? Well, if I'm at -4 and I go to 1, 2, -2, 2 steps, but I took them up, right? So I'm headed towards a positive direction. So then my slope would be -6 over 2, which would be -3. So I now know what my slope is, no longer a mystery. My slope would be -3. Now I just need to figure out where this pattern starts, what the starting point for this pattern is. So again, to find that starting pattern, we're going to use point slope. So I'm going to take y minus y1. And again, it doesn't matter which one you pick. Sometimes I just pick the first one just out of habit, but it doesn't matter. So you have y minus 1 equals the slope, which is -3. And again, I'm just following this right here, right, from the toolkit. And then times x minus x1. Be careful here because there's already a minus there, and then that's a negative. I always put parentheses just so I can kind of catch that. So really what this is that this is really x plus 4. So be careful with that. And then so we're going to distribute into this, right? Take that -3, not a +3, it's a -3. And so we're going to distribute into that. So we've got y minus 1 equals -3x minus 12. And then if I add 1 to both sides, I get y equals -3x minus 11. So that means that my starting point, my y-intercept on this one, is -11. So I'll go back and update that. All right, so that finishes our review. Now you'll finish up the last question on the Edpuzzle, and then you'll be all done with the Unit 3 test retake. Hopefully this was helpful, and you were able to make a little more progress on some of these topics.